There we go. And do you mind if I put on captions too?
Oh, yeah, good idea. Yeah.
Show captions.
I have to say, I do like how you coordinate your hair with her shirt.
There we go. Okay. I think that we're good
I don't
now.
think she wanted to coordinate
Yeah.
her hair with my.
There we go.
Okay.
All right. Well,
Self-introductions.
hello, everyone. So this is another sort of safety, departmental safety meeting that we've prepared for, and so we have Nancy Rolstad and Jodi Ogilvie today, who are going to talk to us. In particular, Nancy's going to talk to us about biological safety. So if anyone's working with microorganisms in the labs or even other types of biological materials, this talk will be relevant. We are recording the session as well, so it should be available afterwards. We're taking attendance, so please sign the attendance sheets if possible. And we have a survey as well. So, but thanks both for being here today, and we're looking forward to your presentation today.
Awesome. Thank you. Do you want to do a quick introduction first, or do you want to?
I'll do my biosafety section second, and I'll give myself a little introduction at that time, but we'll let Jodi get started. This is with the kind of overall safety, all the other things that are not bio.
Yeah, so I'm Jodi Ogilvie. I'm the Lab and Research Safety Manager for the University of Minnesota, and I'm currently the interim research safety partner for CFANS and also food science and nutrition. So previously used to reach out to Evan Engman, but now while we're working on hiring a new position to fill that, but you can always reach out directly to me if you have any questions. I know we've had a lot of new staff members, new PIs come on board. So I'm going to see if this actually switches. Okay, can you see that it changed?
Well, it's still showing the screen at the minute.
Okay, hang on 1 second. I'm gonna stop sharing and then I'm gonna
I'm
reshare.
so glad I'm not the only one to be.
That's
I teach
okay.
class, and I have not been able to get that to work.
And it seems like every time we go to do something, it changed it.
Is it working now? Good. Okay, so just a quick overview of my portion of the presentation. I'm gonna go through a few quick lab safety reminders, but then I'm gonna save the remainder of the time for Nancy because you have a lot of really biosafety specific questions. So I'll go through the UHS service partners and the college service partners, safety partners, some safety training reminders, a few incidents and lessons learned, and then just briefly about ergonomics before transferring to Nancy. So let me know if it doesn't advance. Did it work? Good. So a reminder about department safety officers. Department safety officers act as liaisons between their departments and university health and safety. DSOs often help with more of the college or building specific safety questions that the UHS service partner may not know. Obviously, your safety partner is Stephen for food science and nutrition.
Yeah, and I mean, you should also include Kendra and
Yes, I will include you in the, yes, I will include you in the actual, it's just not on like our website, but I'll include you in the notes. But I wanted to remind you that that they're all part of a larger kind of safety institution for CFANS. So all of the department safety officers within CFANS also serve on the safety committee. And this is just a list of all of the departments and all of the current safety officers. So we meet about every other month, I think, maybe monthly, I guess. Some of our safety committee meet every other month, but CFANS is also unique in that they have a safety committee for all of their departments, but then they also have a safety committee specifically for their research and outreach centers. And some of these people serve on both of those committees. So I just wanted you to see how you're connected to kind of like the greater network of safety. And oftentimes university health and safety will reach out to the safety committees if we have any new initiatives coming up that we want feedback on. And that's how we get the information back to you to kind of get feedback on those from us. And Nancy and I attend those safety committee meetings as well. The safety partners for CFANS are obviously me in the interim and then Nancy. I'll send you these slides. I just wanted you to have our contact information. Right now, I wanted to go over a few training reminders, just the general training requirements here. First and foremost are the lab safety core modules. So if you're a new faculty member, we're going to be revamping them, and it's possible we may have more frequent requirements to take the modules, kind of like your bloodborne pathogens module, if you ever have to take that. But for now, the core modules for general lab and chemical safety are intro to research safety, chemical waste, are ones that are relevant to this department. And then there may be other modules depending on your hazard. So Nancy will probably talk about some of the biosafety modules that you're required to take depending on your work. And then there are some other hazard specific ones. Another key safety training requirement though is the lab specific training. And let me see, I don't know how to get my mouse over to that screen to get it off. Can you can't see it on yours, but you can see it on the projector.
I don't see a cursor right now.
Okay. So there it is.
Oh, yeah, it's here.
There's, for those of you online, the bar is kind of blocking a little bit of the slide. Anyway, so for lab specific training, all faculty are required to train their workers on lab specific hazards initially and annually. And what this covers is it covers anything that your workers are going to be exposed to in your space. So University Health and Safety can help with that general safety training overview, general requirements at the university. But we need you to track what's the specific hazards in your lab. So specific equipment, types of chemicals that you may, that they may encounter, biological hazards and things like that. So we always rely on the supervisor, the faculty supervisor, to give that training. The training can be delegated to a qualified lab safety manager. And I'll talk a little bit about that when we get into the incidents later on. We had one student training another student and they omitted a really key piece of safety information. So if you are delegating that training to your to a staff member, just make sure that they're giving it in a way that you would approve. And then also the training must be documented and those records must be kept for 5 years. So often when UHS comes through for safety inspections, those are the records that we're looking for. Some examples of what would be on that training would be any relevant general chemical safety hazards, chemical, physical, biological, where to find appropriate hazard information, so your SOPs, your safety data sheets, and then also any specific hazards that are very specific to your area. So equipment that you might be using, anything that may have, you know, equipment that may have physical hazards or pinch hazards, things like that. I updated the lab specific training log. So if any of you have an old copy of that, it has a lot of broken links in it. If you go to our website, this link, when I send my slides, has the new version that has all of the updated links from our webpage. And that's a really good resource. Some additional training or task specific topics may be required depending on what you do in your research. Some examples throughout CFANS could be respiratory protection, agricultural tractor safety, not necessarily applicable to this group, but in other areas in CFANS, safe use of anesthetic gases, formaldehyde, things like that. So there are some topic specific safety trainings that you may need, and that's something that your UHS service partners can help you determine. I'll go into a few lab incidents and lessons learned now. So we had a pretty big explosion this past kind of summer into the fall on the Minneapolis campus. And it had to do with incompatible waste. And so what happened was a researcher was cleaning their stir bars with piranha solution. And that's a really oxidizing acid. Sulfuric acid, hydrogen peroxide, it's a really strong oxidizer. And their last step after their water wash was to wash them with acetone to kind of dry their stir bars off. And when they did that, they put the acetone into the waste bottle and then it detonated. Yes.
Was this at Smith Hall?
It was in Amundsen.
Okay.
Yeah.
I thought I heard something about it
There-
happening at Smith Hall, somewhere in that area.
There have been a few explosions in Smith Hall. I was in the chemistry department when I was a postdoc, but this one was in our chemical engineering department.
Okay.
Yeah. And so what we think happened was it formed triacetone triperoxide, which is a really shock sensitive chemical. Heated reaction could have detonated it. The researcher immediately went to wash their face in the eye wash. They actually had goggles, a lab coat, and a mask on. They were wearing like a mask for COVID-19 purposes. And then because they went to the ER mostly because of concerns with hearing because of the boom of the detonation. So they didn't really have any like physical injuries that they could see. So it wasn't like a call for an ambulance type of situation. But then they called UHS for evaluation as well to figure out like how to deal with the cleanup. So this is the waste bottle that ruptured. It was a plastic bottle What went right in this case, I always discuss what went right. So what went right was that they were working in a fume hood, they were wearing the appropriate PPE. And again, it was goggles, lab coat, gloves, and a mask. And the mask, again, was not for their work, it was just for kind of pandemic protocol in their lab. They were working during normal business hours, and they have lab mates nearby that could help escort them to the eye wash. And then the lab had this really amazing decision tree. So this was like an emergency decision tree that this, and I can send this to you as well when I send the slides, just a copy of it. It was something that their PI, who I think was from the California system, really, he's really big into safety, and he had this for them to follow. One thing that I'll say is, usually if there's a personal injury involved, we advocate that you call 911, just because we don't want you to have to kind of make that decision of what's an emergency and what's not an emergency. Just call 911 and ask for medical assistance. Because we have had situations where people have been escorted to the ER while they're like bleeding, and that's not optimal. In this case, though, the lab did the right thing. So what we found actually was that the staff member who performed this, the faculty supervisor didn't know about it. So in their lab, this procedure wasn't really allowed. The staff member was doing a procedure that was commonplace in their prior lab. And so they just hadn't had that conversation as to what the baseline risk tolerance was for that lab. So I think that's also really a really important learning piece too for faculty supervisors, is just anytime you have a new staff member come in with prior research experiments, establish that baseline for like what's an acceptable level of risk in your space. The second injury was UV light exposure. We had several of these come through in different ways, like within a week of each other. So for this particular one, a researcher was imaging a gel for the first time, and this was a situation where they were imaging it and they were actually cutting bands out of the gel. So they were really hovering over the UV light. It wasn't a situation where they looked at it and then took it off. The researcher was trained on how to do this by a lab mate, but they weren't trained on what the appropriate PPE was. And so they were doing it without, any UV protection on their face. And they sustained severe UV burns to their face and eyes that required medical attention and continuing medical attention. So it's just a situation where a low hazard or seemingly low hazard procedure, right? And the UV lights, at least on some of the labs that I've worked in the past, are pretty ubiquitous. I think people forget that there's that possibility for like skin exposure, and especially eye exposure is particularly dangerous. And so in this particular case, again, with the UHS investigation, we found out that the researcher wasn't properly trained on the specific safety protocols. This, we weren't able to identify so some of the UV lights have a little symbol on them that like tell that there's a hazard, and some of them are so old that they don't. And so it's just a reminder of looking at your equipment. If it's old, it doesn't necessarily mean it's bad. It just means that you may need to put an additional sign on it to communicate those hazards. So we've revised our UV light fact sheet, and then we're working on creating a safety alert to just kind of send out to the greater research community. Because again, this type of work can be kind of ubiquitous, but this brings up the point that faculty are ultimately responsible for ensuring that their employees are properly trained. So in this case, a senior level graduate student was training an a new staff scientist in their lab. And they omitted a piece of information, and that's ultimately what contributed to the exposure. Some general emergency procedure reminders. This was actually in your last presentation, but I just wanted to throw it up here in your slides just in case. If a personal injury occurs or a fire occurs, always call 911. Stay on scene to talk to the, usually it's like the fire department that comes, they're usually incident command. Stay on scene to inform emergency responders of what happened, if there are any continuing hazards in the space, and then other hazards that they might want to be aware of. Notify University Health and Safety as soon as possible. We don't have to be notified like before you call 911, but it's good to notify us right away, and we'll oftentimes be called by them just to help evaluate the situation in terms of like the chemical hazards or any other potential like biological radioactive hazards as well. Notify your department safety officer and also your department leadership, because the last thing you want is that for your DSO or your department head to like find out about it on the news or on Twitter. So one of the Smith Hall explosions, the picture of the blown up fume hood blew up on Twitter before we had really announced it. And so That was how the information about that got out. So it's always good to make sure that your department, knows about it. I have some additional reading for UHS emergency procedures and chemical spills. That's on our website there. There's some fact sheets. But it's always good to plan for emergencies, because when you plan for emergencies, people are usually less likely to kind of panic in those instances. It's kind of like second nature. The last thing that I wanted to say before I hand the floor over to Nancy, just a reminder about our ergonomics program. So many people may not know that we have an ergonomics program. So we have one of our industrial hygienists does ergonomic evaluations. We have a showroom in Boynton, and it's open every Thursday. There's hours. I have a link to the ergonomics program webpage on the second page, and that gives you all of the information. But one of the leading causes of workplace injuries is really, ergonomic injuries or repetitive tasks and things like that. We think about it a lot for our office workers, but we don't necessarily think about it for our lab workers too. And so there have been situations where our industrial hygienist has gone out and done an ergonomic evaluation in a lab situation, especially if we have some places on campus where the equipment is like at a suboptimal height, for people, or benches and things like that. So they can help give you some resources for that. And then also during the pandemic, we found that we had a lot more ergonomic injuries from people working at home in a desk area that wasn't really set up for them, like their office area might have been. And so we just have a quick fact sheet on that and kind of how to optimize your workspace at home. The evaluations are free and available to all U of M staff and graduate students. And there's reimbursement available for approved ergonomic purchases. So like if you go to the ergonomic showroom and you find a chair that you really like, we can reimburse a certain percentage of that purchase. And they can help you work through that. And then again, we have a showroom in Boynton, or they do in-person office visits too. And you can visit this website. And again, I'll send you my slides. So that's really my information. And what I'll do is I think it might be best for Nancy to go next, because I think you're going to have more questions about biosafety. But if you have any questions for me, I'm happy to answer them maybe at the end. I'll let you
See if I can get it set up.
Yeah, so let's see. Yours is on here. Yes. And then let's see if we can make it big.
Is that showing up all right for you?
Yeah.
All right, okay. Thank you, Jodi. I'm Nancy Rolstad. I'm a biosafety specialist, a registered biosafety specialist through the ABSA International, which is a professional organization for biosafety specialists. And my background here at the university before I took this position was I've worked in 3 different labs as a molecular biologist, molecular virologist. So that's really my background. But I really enjoy this position because I get to go around and help people work safe, because I was always the safety person in the room. And something to think about is our department, biosafety, is going to be hiring a new biosafety specialist soon. There will be the advertisement for it coming out soon. And so I'll be sending that to all the areas to see if, if there's anyone interested. All right, let's see if we can get this to change. Okay. Lost my mouse. There we go. But it doesn't want to change based on this. Thank you so much, because this is just not.
Yeah.
I'm a grandma now, so I have a good excuse. To
There, I think you can just like.
What it,
I just kind of like.
Oh,
clicked
just
it
tap on
with
this.
the mouse pad.
I'm gonna put that on the ground.
All right, so the Biosafety and Occupational Health Department, short is called BOHD, and that's the department I come from. But we are combined with occupational health, and sometimes people are a little confused about what that all covers. Our occupational health department is an administrative department that helps people reach the occupational health physicians and or oversees a lot of the programs to help keep people safe in all sorts of areas. So the biosafety part is what I'll cover, and that's what the rest of this presentation will be about. And that has our main link. And the occupational health information, the links here. And so it's a good idea to visit this page just to see what's offered. Some people don't even realize that if you have an injury at work, that everything's paid for if you need to have that follow-up care. We don't want people to not go to the physician because they're worried that they're going to get billed, and they won't. If it happens at work, it's covered. So planning to work safe, then this is the rest of the presentation will be about how we deal with making things safer while you're working in a lab. And even, I mean, this covers office space and everywhere too, but one of the things that safety professionals work with is this hierarchy of controls. If you've ever seen this before, the one at the top is the most effective. If we can eliminate that issue, whatever that might be, you're working safer. And then substitution is if we can replace something for something less, say less toxic, less virulent, less physically dangerous. Engineering controls are keeping people something between you and the hazard. So think of like a biosafety cabinet is an engineering control to help protect you from the hazard. The administrative controls, that's how we work. Those are our work practices. That's physical training. That's how we would work through a process and learning how to do things safer that are under our control. And then at the bottom, we have PPE, and that's our final thing. We never want to rely on PPE as our first line of defense. And so you can see that's the least effective. If you just throw on some PPE and you don't work properly, or you don't have those engineering controls, you are at higher risk. As we're going through this presentation, I want you to remember that what you work with can make you sick. Don't bring it home. We have had, there have been laboratory acquired infections by people's children, meaning that they brought home something and got their children sick. So thinking about that's, we'll talk a little bit about lab coats, but thinking about before you leave for the day, washing your hands for sure every time you're leaving the lab, not having personal items in the lab, or if you do, think about decontaminating those like your cell phone or something before you're taking it home. And or as you're arriving home too, to make sure you're thinking about where you leave your shoes that you might have been wearing in the lab, not where someone can access them. There's a link to print this poster too. It's from the CDC. So the laboratory acquired infections that I mentioned, the accidental routes of exposure are pretty much the same as any routes of exposure. We've got ingestion, inhalation, mucous membrane contact, or inoculation from a needle, poke, or a sharp injury. And most of the time the potential causes are caused by cross-contaminated surfaces, aerosols being generated while doing work, and or sharps injuries. And for laboratory acquired infections overall, oftentimes you can't really trace it back to an event. That may be that someone becomes sick and they're able to say, yeah, it was the laboratory strain, but that person and or no one is reporting any incident that ever occurred, like a poke or a sharps injury or anything. So that's why all of those things that we're going to talk about working safe are so important, because you don't know when it's working. And that's actually a good thing if it's working and you don't know that you may have been potentially exposed, because if you're exposed, then you're sick, and we don't want to get to that step. Preventing laboratory acquired infections is usually the best one, besides cross-contamination, being clean. The aerosol producing is one of the things to really worry about, and that actually can create cross-contamination too. Something aerosolizes over here, gets on the countertop here, you come back later, touch it with a bare hand, you go to lunch. There's a chance that you're going to cross-contaminate. So any equipment that you use that puts energy into a system of, especially a liquid, but sometimes it can happen with something more solid, can create an aerosol that could be cross-contaminating or actually just inhaled, including spills. When you have a spill, things can go farther than you think. To reduce the aerosols, we want to use some engineering controls and some work practices, those administrative type things where you're learning how to do things. The term in that hierarchy control where we got to that administrative, that's the work practices, and that's how you're going to really hear me talk about it, because it's what we're talking about, how we work. Using a biosafety cabinet for anything that you can for, especially like vortexing and centrifuging when you're able to put that in there. The middle picture there is using a pipetter. So that pipetter, when you're actually emptying out the bottom of a pipette tip with your liquid, keeping it under the level of the liquid so you don't create a little poof of aerosol. And the top picture here is of safety cups that go into a centrifuge. It's an actual physical cup that comes out of the centrifuge. You put the top on, has an O-ring that can then be brought into the biosafety cabinet to be opened. And in the bottom, having a spill kit available so that when something does occur, you're able to respond to it right away without having to really run and panic to find things. Risk assessment is always how you start those work practice ideas. Looking at what risk group that organism is, the things that you'll be doing with it, and determining how you need to work with it. Because we don't need to have everybody working in a bubble all the time. That just doesn't work. If you have too much PPE or too many controls that really don't need to be there. So going through a risk assessment to determine how to do that, how to do your specific work is really important. All of these are resources that you can, and we'll send you the slides too, with all the resources. And so these are things that you can access to help with that. But if you don't have IBC coverage, Institutional Biosafety Committee coverage, they actually go through the risk assessment with you. You create it, they're going through it. If you don't have to have that coverage, our department can help you with a risk assessment because there's an area where the IBC doesn't look at things. And so we can certainly help with that. And I did mention, I'll bring up the BSL-1 lab coat requirement change. This has been not quite a year now, I think. The change in this is that we're adding a requirement to wear a lab coat while working, even in BSL-1 work conditions, because the biosafety, microbiological and biomedical laboratories, we call it the BMBL for a reason. That is the guidelines that we follow at the university here, and they have added wearing a lab coat in BSL-1 conditions, and so we are following that. And so there's been a little bit of challenge because sometimes we have trouble getting people to wear a lab coat in BSL-2 conditions. So we're going to be cracking down, and now there's really no excuse. If you're actively working with materials or right next to somebody who's working with it, a lab coat should be worn. If you just are accessing a lab, like you're walking in to go use a computer in the corner or to get something and then you're leaving, you do not have to wear a lab coat just for that activity. But if you're coming in to change the biohazardous waste, then the lab coat goes on, that kind of thing. I'm going to talk a little bit through autoclave safety here. It's not specifically a biohazard in itself, but we use it for biological materials in a lot of areas for decontamination. And so I've just kind of been in charge of helping with that. There's an autoclave in that room. This is not the exact picture. This is a picture from another university, but we had an incident, I think it's been a little while now, where the autoclave door was not shut tight. It was one of these kind of older style where it has to be turned to get it, and it tightens up as it goes. The kind that have the drop down doors, or you just push a button and the door closes, those have all those mechanisms to say the door isn't shut. Some of these older ones, there's nothing on here that's going to tell you didn't get that door shut tight. So if you're using one like this, tighten it really tight. And what happened, it didn't quite close, steam was left. The person who had started it left before it was up to pressure. And you really should stay in the room to see that the autoclave actually gets up to the proper pressure before you go, because even if it's one of the more modern ones, it might abort the cycle and then you come back the hour later and nothing happened. And now you got to start again, or you've been using up that time. The user log that was for this autoclave did have some writing in it, but no one could tell what it said. So we didn't even, it took a while to hunt down who had actually used it last. So for autoclave use, especially these are a lot of times in shared areas or they're shared use in someone's areas, we want to have a designated person that's responsible for the autoclave maintenance, making sure that the room is clear, that everything's running properly, and posting notices. They should also be providing individual training for every new user. And even if you have someone coming in saying, oh yeah, I've been using autoclave for years, we need training on that individual autoclave. We have probably 50 different kinds of them on campus. And even if it's the same brand, newer ones have different techniques. Providing contact information so that people know how to report an incident, or see if they see something, they get there to use the autoclave and there's something messing it, who do they call? And providing that log and requiring them to fill it in so that you have, somebody else comes in and they see there's an error on the autoclave, they can look in that book, go find the person and say, I see there's an error in this, and they can let them know. For the user, their responsibility is to never use any equipment if they've not been fully trained. It's perfectly fine even if you've been working in lab for years, to tell someone, I just don't know how this piece of equipment works. Let's just go through the training and not just assume you know how it works. Asking questions about anything you don't fully understand, or even if you don't remember, you may have had the training 6 months earlier and now it's the first time you're using it. It's okay to ask questions again. Filling out the autoclave book legibly, the type of load that's going in there, and a way to contact you, a name, lab number, phone number, cell phone number, any way, whatever works. Same with the autoclave for a bit as it starts up to make sure it's going. And then setting a timer. Sometimes you might have to get to know your cycle in that autoclave to see how long some of them literally do only take an hour, and sometimes it might take an hour and 15 minutes. So learning how long it takes for your cycles. And checking the door seals every time. This is one thing to do when you open up an autoclave. There's always going to be some sort of a door seal. They might be red, they might be blue, they might be black, but just taking a quick peek at it to see that it's intact. There's no rips or tears or anything stuck to it. And there's always a drain screen in the bottom. So I have it kind of blown up there. You can see it's usually towards the front. And if you look down in there, you always want to take a peek in that area to see that there's nothing that's fell in there too. Sometimes all sorts of things have fallen in there, and nothing should be getting loose in that section of it, but it does happen. So keeping that open, that helps the whole cycle work together. And if anyone's ever interested on how an autoclave really works, I can do some really specific training on what it does. And there are different types of settings. The gravity method is, a lot of the older autoclaves are this is all the only method that they have. This works well for the biohazardous waste, glassware, and unwrapped goods. There's a vacuum method that runs the whole cycle a bit faster because it's pulling the air and pushing it out so that you're not having just to wait for it to settle. That also works well for like the wrapped loads and packaged goods. We want the gravity method for autoclaving waste, like hard gloves or paper towels and things like that, and it needs to go through there. And then there's the liquid for any liquid biohazardous waste can go through the liquid method, but for water or any of your liquids saline, this has a slower exhaust so that you don't get a blowover at the end as that pressure is being relieved. And so I mentioned liquid boil and boil over or bump, sometimes it's called it. So under pressure, it's like 15 PSI is what the autoclave runs at. And as that's released, if it's released too quickly, it's like opening a pop bottle and all those bubbles come up. So you might have those liquids blow over. That's why it's always advised to never fill a container either half to 3/4 full, depending on what. If you have a lot of stuff in there like agar, half is probably good because you might get more of a boil over. If it's just water, you can probably go a little higher. This is really dangerous because if you open up that autoclave at the end of the cycle really quickly, also, and you pull that tray out, that little shake can set it off too. Sometimes you've heard this happening with people in the microwaves with hot water. If the cup is really smooth and they go to grab it, it can actually send out those bubbles afterwards because it didn't bubble during the heating process. So letting, anytime you're moving liquid, letting it cool for a few minutes before you actually pull it all the way out. You can open the door, crack the door, and then before you're taking it out, let it cool. I have more information on the type of PPE in another section as we go forward. Also using proper secondary containment in an autoclave. Don't want this to happen. It has happened a couple times on campus, and this will melt down and fill up that strainer basket, and it's extremely expensive to fix this. You don't let it be you. polypropylene, which is also known as nalgene, or the stainless steel. We prefer stainless steel actually because it actually transfers the heat better. And you might think like a nice deep pan would be good, but actually a shallower pan is better because it allows the steam to get in a little better and fill those pockets. If it's too deep, you might get some pockets in a pan that didn't get that steam. All right, before I move on to cryo biosafety, I'm just curious what time I'm at. So I got, okay. What, is that correct?
Yes.
Okay. All right, perfect. I usually don't have so much time to talk, so I'm just like excited to have a little more. I can be really spinning through stuff, even though I kind of still am. All right, so for cryo vials, I'm talking about these tiny little vials that you would store your samples in liquid nitrogen. In a liquid nitrogen tank, either a separate dewar that has it that you have to fill all the time, or sometimes we have the big automatically filling liquid nitrogen storage. A liquid nitrogen itself, as it warms, it can expand to like 700 times its size really quickly. And so we did just have an incident only a few months ago of a vial popping open in someone's hand. No major injuries, but you can imagine if that was aimed at your face. The different stages of liquid nitrogen storage make a difference on what type of vial you use. Generally, the vapor phase, which is going to be above, if you've ever looked into a liquid nitrogen tank and you can see, sometimes you can see in there all the way at the bottom, you'll see the liquid kind of in the bottom, but mostly you're seeing a cloud at the top. That cloudy spot is generally sufficient for most long-term storage, and that's where is the best place to keep all your vials in cases it sits above the actual liquid. This prevents cross-contamination, and it also prevents that liquid nitrogen from getting into those vials, which then is more likely that it's going to pop when it gets as it's warming. So the liquid phase, there are certain vials that work well for that, and or vial wraps. And so if this is something that you think you need to do, you need to make sure you have the background on it to make sure that you want to actually have it into that liquid section. The liquid phase storage also is the best to use these, the threads that are, the thread cap that is threaded internally, that if it were to expand, it kind of actually pushes those threads against the vial, and it doesn't let that top just pop off as easily. And following the manufacturer's recommendation for the fill line, because that is often the problem. And the one that blew up, we think was overfilled, because we looked at some of the other ones and they were overfilled. So following that line, that allows then the product in there to have a little expansion as it freezes and not take up too much space above it. And this has the image of the shrink wrap tubing there that would go over the tube and then melts down to help prevent it from blowing off when it's being reheated. Another technique to use if you are using the liquid phase storage is to actually go in there 24 hours ahead of time, move the vials that you want to use, that are in that liquid up to the vapor phase, and then close it back up. If you're doing that rather quickly, they're going to stay frozen. They're not going to pop open instantaneously. So you're moving them up there, then you're closing up the whole dewar and letting them gas off for about 24 hours. That will reduce the ability for them to blow up so easily. Always when you're transporting cryo vials is to keep them, you're moving them in ice so that you help keeping them cooler, but then put a cover on it, because if it does happen to pop while you're walking down the hall, you don't want it to get somebody else's eye, or it's also very loud. I have had one pop as it was thawing away from me, and it popped and just blew up. I didn't get hit by it, but it sounded like a gunshot. It was loud. Sharp safety. This is one we have. Sharps incidents come through all the time through our office. The majority of them are medically related, working with patients, or with veterinary situations. And that's just a little more out of control. You have another moving entity that you're dealing with, and that's often where things can happen. But sometimes it's just a matter of not thinking through what you're going to be doing, and how you're going to work with the sharps. Initially, we also never want to place sharps in the normal race stream. We have had a couple incidents where people have been taking out just your regular trash out of room, and they grab the bottom or swing it around and something pokes them, and we investigated a little bit. We have found needles, we've like razor blades, just all sorts of things, and we don't know where they came from, and hopefully not from a lab, but just making sure that if you are in charge of one, you never place it there. This also includes glass pasture pipettes, those glass ones. Even the plastic ones are pretty sharp, but the glass ones, you know, they're fragile, they break pretty easy. Those need to go into a sharps container or a bag, a box that's lined with a bag. But if they're biohazardous, then the sharps container is the best option for that. Sharps containers need to be puncture resistant, leak proof, clearly marked with the biohazard symbol, and easy reach of workstation. This is the one thing that I'm talking about, that work practice. If I'm working with sharps here and my sharps container is over there, now I'm walking across the room with it, we don't want that. Get those sharps containers, have multiple little ones at the workstation, move it to the station where you're working with it. So once you're done with that sharps, you just set it right in. It shouldn't never be recapped. There are exceptions we'll talk about in a second, but if you're done with it, if it's single use, goes right in there before it even leaves your hand. So we don't have, and that you're thinking about that space in front of you. You know, it's not that I have somebody else here and I'm going to reach across them and put it past them. Sharps that may have high hazard chemicals, chemotherapy agents, or low molecular weight biological toxins need to go into a yellow sharps container because they will end up being incinerated. The red ones get autoclaved, but autoclaving doesn't work for those kind of hazards. And the low molecular weight biological toxins, especially those they'll denature and then they kind of come back together and they can still be active. So we don't want to have those get into the autoclave stream. Sometimes these yellow bins are hard to find. We can, if that's the problem, we can mark them to say that it needs to be incinerated, but I want to, if that ever is the case, if you can't get one, let me know and we'll make sure that it's fully marked so that it doesn't get into the wrong stream. No recapping before disposal, close to your work area. Another thing is to verify that the needle is laying horizontal in the container. We did have an incident a while back where the container was getting a little full. Few needles were poking straight up. The next person came along with theirs to drop it in and caught their finger on a previous needle. I like the kind of containers that are kind of see-through, red, but you can still see through it so you can see that line a little better. And you'll notice the lines are actually really low. The full line is pretty low on those containers on purpose to help prevent that. But if you see anything in there that's out of line, if you hold the outside of the container and give it a little shimmy and help lay them flat, make sure that when you put it in there that yours went flat so the next person doesn't come along and poke their fingers. The few exceptions for recapping, if it does need to happen, there needs to be a written SOP and I would like to review it because we're going to see which method is going to work best for what you need to do it for. Dental work, a lot of times they do have to recap their needles because they use that over and over in dental situations. And so we work with them how to do with that. Lab work, occasionally you might be dosing a small, just you're watching the mill, you're putting a mill in something, then you're going to do it again and again. We need to find a way to keep that safe in between. Some of the methods are having a recapping device, which is like a sturdy little metal or plastic cone that the cap goes in. So as you're coming up, you got one hand coming down with that needle going into that and you tighten it down on the lid. The one hand scoop works well. It's just the cap on the countertop and you scoop in there and lift it up. But verify that it's there before you go to do this, because we had someone do this and it flung off over their shoulder and a finger came down on it. Only caught their glove, didn't catch their finger, but they just were so used to doing that. It was just a scoop and oops. So those oops moments that, you know, they were lucky. The rigid tray also works really well. If you're working on it and you have to be able to see it a low side, but something where your hand won't scrape across and catch that needle if you're doing something But you can look in, pick it up, use it, and put it back. Talked about the fill line, you can see that it's not that far up to the top. When you reach that point, you take that top over, snap it down tight, put a piece of tape over it, write full, and then it would go out however is designated for your building. This is where DSL comes in handy because they can help you know where to do it, because every building might do it a little different. Sometimes it goes by the regular trash and it will get picked up, or it has to be brought to a designated site. And don't forget that broken glass is also considered a sharp, and substituting plastic glassware wherever you can is helpful, so you don't get anything breaking. Broken glass that is contaminated does need to go into some sort of a sharps container so that it will be treated properly later. If it's not contaminated, it can go into a broken glass box. That broken glass box, nothing, it just ends up being wrapped up and thrown into regular trash. It does not get recycled. It doesn't get decontaminated. And so same thing here, if you had broken glass, if it had by the biohazard, a chemical hazard, if it has a radioactive hazard, then you want to talk to your radiation department partner to see how to dispose of that. Oh, all right. So broken glass often is also creates a spill. And so I'm going to start going a little faster through some of these sections so we have time for questions in the end, because I did get those questions ahead of time and I want to address those where I can. Spill response, Jodi talked a bit about it too, but just knowing before what kind of incident you might need to respond to and having a kit that's appropriate for that. And we have a lot of resources on our website, knowing when to evacuate or when to remain in place. If there is a radioactive spill, you do remain in the space. You don't want to be walking through the building and potentially bringing radioactive materials around with you. You can move away from the spill a little, but that's not real far away. During the incident, making sure you're notifying the others, you're evacuating or remaining as necessary, restricting access, and responding to any first aid that you might need to. If you're not sure if you need to dial 911, then go ahead and dial 911, because if it was just a paper cut or a tiny poke, you're not thinking, oh, I need an ambulance. You still need medical follow-up and everything, but it's not necessarily a 911 call. If the spill is large, and even if no one's injured, you can still call 911 if you think you need help cleaning it up. Clean up, making sure you're using your proper PPE, and if it's human blood and or human materials, following the blow-over pathogen training and disposing of everything properly through the waste, the proper waste line. PPE. For using an autoclave, we need to see safety goggles that help with a splash. The face shield is even better because that protects the rest of the skin on your face. Using a proper glove. A lot of people have the orange, like Elmo gloves, and those are really good for high heat, dry heat. They don't protect against wet spills. So having a thermal rubber glove, and it has to be rated for something higher than what the temperature that you'd be dealing with, works well if you're doing a lot of liquids, the auger, anything that might have a boil over. And if those orange gloves are already wet, so say you go in to get your dry load out, you're just taking out biohazardous waste and you're going to grab that bin. If those orange gloves got wet by somebody else, do not touch anything hot. The liquid will turn to steam and you will get a steam burn on your fingers. And don't use your liquid nitrogen gloves, because they'll help a little bit, but they'll ruin the gloves. So working with liquid nitrogen, the opposite then is not to wear those orange gloves because they are permeable. You can see also a face mask, a face shield, and lab coat, and of course your full PPE, your covered legs and everything. I think I have another slide here, but yeah, here we go. Legs always covered, long skirt, long pants, closed-toed shoes. We say closed-toed shoes, and that's appropriate. But if you look at like this, the tennis shoe that has a little caution sign by it, Those are like those really airy ones, and if you spill water, it goes like right through. If you ever walk through wet grass and your toes are wet, they're not going to protect you as much in the lab as they would, you know, help a little bit maybe if broken glass fell from a cut, but they're not going to protect you from a spill of something corrosive or really hot. So thinking about a solid toe. Wearing your PPE in the proper places and not in the not proper places. This poster, you can, there's a link here to print this poster. I have not been able to find out who actually made this. So whatever department made this, it's great. But I've seen it in several buildings, so I'm sure it's free to share. If you need to carry samples through a hall wearing one glove to hold the sample and using an empty hand to handle the doors, or thinking about how, you know, touching your own personal phone with a gloves and then taking your gloves off later and then grabbing your phone and going to lunch, you know, that cross-contamination. There's a couple of links here. This has a link to this poster about proper glove removal, and there's also a short video clip of showing how this goes through this. The key points here are gloves should always only touch the outside of the other glove, and and bare skin should only touch other bare skin. So in the technique, the first part is you're grabbing the glove to start rolling it off. And the second part, the key is your fingers are going under the glove, your skin to your skin, and rolling them off. And always washing your hands after taking gloves off, because you never know if you did just touch something and get some cross contamination. And I'm going to just a couple slides on this. Using the right hood at the right time, knowing what cabinet does what. And this, I'm not going to go into depth with this, but I do offer in-person biosafety cabinet training and go over the differences of these and how to work in them. We have some fact sheets here that you can come to, but not all of these work the same. Some provide protection to just the product so that you don't contaminate it. Some provide protection to just the person, so your product can get contaminated if you're concerned about that. And some provides both. And some work for chemicals and some don't. We also do not want any open flames in a biosafety cabinet, and so there are options. So if you ever need to use an open flame in a biosafety cabinet for something, this is another thing that talk to me about, and we'll make sure we get you set up with the right things. Biohazardous waste. We talked a bit about it already, but knowing which waste stream to use. We have our website for and fact sheets. The gray bins with the red bags get autoclaved off-site, so that takes anything that's biohazardous that is not required to go into the other two bins. So your gloves, no liquids, but your gloves, paper towels and things like that. The red bin with the pink digestible bag, that takes animal tissues and that gets processed through the digester. And the yellow hazardous waste, I talked about what went in their chemotherapy drugs, low molecular weight toxins, that those get incinerated. And also if you have animal tissues that cannot be sent to the digester for some reason, it has an implant or some plastination, those go into those yellow bags as well. So all this waste stream, if you have questions about where something should go, get a hold of me, we'll hunt it down. There's always something. That's one of my big questions, always getting something new. Biohazard bags for autoclaving need to be clear with no symbol, because they do go into our regular waste stream afterwards, and we don't want them having any symbols on them. But autoclaves that are being used need to have a chemical integrator run at least once a month if they're being used for decontamination of biohazardous waste. I forgot to add the link to more information on this, and I'm going to update a couple other links because I know they're broken before I send this out, but you'll have access to these afterwards. And our biological safety training requirements, the page at the bottom here will tell you which ones you need for your lab, but the first two are the first one is the one, sorry, this is in a different order than I had on my other one. The second one is required for everybody, and the rest are dependent on what you're working on. Bloodborne pathogen training is annual. If you have any human materials that you work with, cell lines or other potentially infectious materials that may come from a human. And this is where the specific trainings that were on the other page. Other requirements oversight is institution biosafety committee and multiple ones listed here. If you have, we're gonna have a new page that's gonna help you work through what you need. It's gonna be a little while before that's ready, but if you have questions about what oversight you need, you can get a hold of me directly and I'll help you get to the right department. They're all separate from our department, but we work together. And covering kind of the things I can help you with. I've talked about a lot of this. I can help you with SOPs, biohazardous waste procedures, biosafety cabinet training. And we're still, we still have challenges on campus. So I always like to still just throw in the link about the COVID-19 updates and or safe campus. So you have access to that. There's not a lot going on with that now, which is great. It's like, as soon as that's, out of our hair, it's really nice. I have my contact information here, but I also, I got a couple minutes? I had questions came in ahead of time for about, a lot of it seemed to be about IBC related. But I do want to touch on those. One of them was about ATCs calling an organism as BSL1 and then working with it, needing to work with it at BSL2 because the IBC said so. It's mainly because ATC doesn't know what they're doing. They put their recommendation for that as to how they can ship it. And some things when you're not working with it, it's fine. You can ship it that way and they can, and so we've always had a challenge with them. So ultimately what you can do is if you're in that, have that case come up, you can propose the biosafety level that you think it should be used at. Yeah, IBC reviews it and then they're going to come back with their recommendations. It's perfectly fine to go back with them and say, are you sure? Because we're only doing this or something that sometimes there's a disconnect between what they're reading and what's actually going on. So I think it's perfectly fine to have a conversation with them. There was a question about IBC protocols, was it if there's any difference between the teaching and research, and there's really not a big difference between how they look at it or review it. The big difference is that students do not get registered on the IBC protocol, and that it's then the instructor's responsibility to provide all of that safety training that they from the IBC. Let's see, if IBC protocol needs to be passed to a new PI, it can be done as almost as an amendment. So they just contact the IBC and tell them the situation. That whole protocol can usually just be reassigned to a new PI. If there's room space changes and stuff, I might have to come out and visit it or verify that there's been an inspection. But it's really actually, and it happens quite a bit where PIs transfer that whole protocol to another one. Let me see if there's, does anybody have any questions here, or has any questions come in on chat? I don't think so. Yes.
So we have some topic of so how we discard them.
For disposal?
Yeah, disposal.
Um,
We don't need it anymore.
Okay, yeah, so just if is it in liquid or solid?
Solid.
So in solid form, it could be disposed of in a red bag. Just package it up so that it doesn't, that it might not leak or something. But if you have it even, whatever it's packaged in, and then put it in the red bag. Yeah.
Which one is
Okay, yeah, so
sealed?
the whole container can just go into a red bag if it's a solid.
And then
And then it gets sent out with, let's send it out in a red bag. If you need more specific information on how to do it for this building, you can let me know.
okay, yeah, send an email.
Are we at time? We've got a little bit.
One question, and
Yeah.
this kind of always comes up in discussion too, is and just the whole new idea about lab coats and hallways.
Okay, yes, that was another one on here. I knew there was one more I missed. If you're going directly from one lab to another because you're working and you're like maybe moving samples, or you're doing something in this lab and walking across the hall to that, no gloves on door handles, leaving your lab coat from that to that, I'm fine with. Walking through a very busy spot, like where there might be a bunch of students studying, or through food areas or into the bathroom, no. So leave the lab coat where you're at. If you have a long ways to go between two labs, like say you got to go down 3 flights of stairs, and have 2 lab coats. You can buy just a disposable one for the lab that you might not be in as much, or just have 2 of them. switch out from one, switch out to the other. If you are moving samples that far, you leave the lab coat, one glove on your samples, or put the samples in a secondary container that's wiped down, and then you can carry it without gloves all the way down there and reopen it. The samples should be in some sort of secondary containment anyway. If you're going just across the hall, it should still be in a tray or something, so that if it did get bumped or dropped, it's not gonna be a big spill.
Is that just for chemical lab coats or is that also for biological lab coats?
Both,
Okay.
yeah.
So it is okay to leave the lab.
Jodi, do you have anything more specific? Because then like, so I'm really, like, if you have a really chemical heavy lab, how do you do that?
Yeah, so, actually, when I worked in the chemistry department, we had a couple different lab rooms that were not attached to each other. And so we would continue, but they were in the same hallway, so like the hallway had a couple different doors. And so what we would do is if we needed to transport things between labs, or if we were going between labs to get stuff, we would still wear our lab coat because we're in the hallway for such a short period of time, and our hallway was like really kind of locked down, like you wouldn't be in there unless you were going to one of our labs or our PI's office. And so we did that, but I've seen like groups, walk through, especially in some of our areas on the Minneapolis campus where like the different buildings are attached through skyways and stuff. I've seen people like walk through skyways with lab coats, and I would discourage that. However, if you're transporting samples or something like that, I definitely have seen people take their lab coat off, kind of hold it over so the outsides are touching outsides, put it on the bottom of a cart and then move it with it, and then put it back on when you get to the lab. So you can transport, I think it would be
Yeah.
okay to transport your lab coat with you as long
Yeah.
as it was in a controlled manner like that.
I guess we're at time, but I was gonna ask a bit of a question about, now that we're starting to have lab coats for BSO1 work, sometimes it's a little bit confusing about what might come under BSO1 and what might just be lab work, right?
Yeah.
Yeah, I mean, could you give us some information about what might be classified as BSO1 or direct us to a site and check out?
For the lab, the other lab work, then you'd be working with chemicals or,
Well, I'm just thinking like somebody's working with plants or something. I mean, it's not necessarily hazardous, but
yeah.
it's something like that.
So I think if we, on an individual basis, let's look at those. So if someone has a question, I'd love to come out and just look at what they're doing so we can actually talk through it, because it's hard to give a blanket statement for that. It's that risk assessment. And it's always a good idea to protect what you're wearing anyway. Like plants can have allergens and stuff that could get on your clothes and come home and, cause a rash or reaction with someone else. So it's always a good idea to protect whatever. I think the main thing is like, if you're in the lab and you're just going in to get something, or you're working at a computer station in the corner that's not near work going on, that's pretty much the time that you don't need a lab coat. But if you're actually near the benches and stuff, most likely it should be on. I know there might be people who had to go online, or if anybody has to go here. But there was one more thing, and then the recording, at least people can catch up with that. The food grade waste, fermentation waste or whatever. We actually started looking through this, and then absolute sir, I saw someone bringing up the same thing as how do they deal with food grade waste. And currently it's going to stick with being treated as biohazardous waste, as like risk group 1. It would just if it's liquid waste, get bleached with the 10% bleach solution for 30 minutes, then it can be poured down the drain and extra water run. If it's something that's more solid, it could be collected in the red bag or autoclaved. So unless, if there's, I know we have some specific food service or food, what do you call it? Food safe labs. And that's the area where I need to look into a little more, and we hadn't thought about it. So this is good. Jodi, do you have any background on this one?
No, I think that's
Okay.
actually a really great point. I think that's a good, it's not something I've really considered in the past. So I think it would
Yeah.
be really great to, especially if you have specific cases coming up, we always love to partner with people and kind of develop resources in partnership, especially because those tend to work best.
Okay, well, I think we're a little bit over time, but thank you to Jodi and Nancy, and thank you for coming to talk to us today.
Thank you. Let's see.
And we'll put the recording on the webpage so that you can access it. If you haven't already, please remember